everyone. I'm going to read the book The Story of Snow, The Science of Winter's Wonder by Mark Cassino with Jon Nelson, Ph.D. It's a Scholastic book. The Story of Snow. Look at all these snowflakes. They always have 6 branches. They're real snowflakes. And they're symmetrical 6 ways. Our story starts on a winter day, high up in the sky, in a cloud that is very, very cold. This is the story of snow. Clouds are mostly made of air, which we can't see. Then there's water vapor, water in the form of a gas, which we also can't see. We do see the billions of tiny droplets of liquid water and ice crystals that float in the cloud. They reflect light, making the cloud visible. Snow begins with a speck. Clouds are mostly made of air and water, but there are also bits of other things like tiny particles of dirt, ash, and salt. Even living bacteria can float in the wind and end up in a cloud. A snow crystal needs one of these specks to start growing. These specks are all much smaller than the eye can see, but if you could see them, you might see ash or soot from a volcano or fire. Salt left over from ocean water that evaporates. Particle of soil. Grain of pollen from a flower. Or bacteria from plant leaves. The speck becomes the center of a snow crystal. When a speck gets cold enough, water vapor will stick to it. If you had a microscope that could see such small things, here's what you would see. Water vapor sticks to the cold speck, making the speck wet. More water vapor sticks to the wet speck, forming a water droplet. The droplet freezes into a ball of ice. More water vapor sticks to the ball of ice, and it grows into a hexagon-shaped ice crystal. Remember, a hexagon has 6 sides. Water vapor continues to stick to the crystal. Faster growth on the corners causes 6 branches to sprout. So can you see these 6 little branches sprouting, and then they're sprouting more 6 branches. The branches keep growing, sprouting little arms of their own, kind of like the branches of a tree sprout smaller branches, which sprout smaller ones. And a beautiful snow crystal is born. Maybe you saw some of these recently when it snowed. I know I did. Look at all the different shapes they can be. These photographs of real snow crystals are shown much larger than their actual size. The crystals were collected during many different snowfalls. So these are actual pictures of actual snow crystals. A snow crystal forms as it falls. As the snow crystal gets bigger and heavier, it starts to fall to earth. It keeps growing as it falls through its cloud, taking on its own special shape. The shape depends on how wet the cloud is and how cold it is. A snow crystal can start to grow one way, but then grow another way when it passes through a wetter or colder part of the cloud. The crystal stops growing soon after falling below the cloud. Snow crystals can be stars. One common snow crystal shape is the star. Star-shaped snow crystals usually have 6 arms reaching out from a center point. The center point is the home of the speck that started the crystal. The 6 arms look alike, but they're almost never alike. That's interesting. Maybe they're not really truly symmetrical then. Parts of a snow crystal can break during the fall to Earth, causing the arms to look different. Ooh, so maybe they are symmetrical when they're formed in the cloud, but they can break up a little on their way down. That's pretty neat. Star-shaped snow crystals are called dendrites, which means tree-like. They form when a cloud is full of moisture and when the temperature hovers around 5 degrees Fahrenheit, or minus 15 degrees Celsius. Do you think we got down to minus 15 here? Well, with the wind chill factor, we almost did. This is the simplest kind of plate crystal, a hexagon. Plates form when there's not enough moisture in the cloud for stars to form, and when the temperature conditions are a few degrees warmer or colder than the temperature range that stars require. Snow crystals can be plates. Plate crystals are thin, like star crystals, but they don't have arms. The simplest kind of plate is a hexagon with 6 straight sides. So this doesn't look like a normal snowflake, does it? But it is. It's like just a 6-sided plate. More complicated plates have points where arms almost grew. Almost arms. This shows the actual size. So this thing is actually just the size of that little tiny dot that you can barely see there. Simple plate crystals are much smaller than stars. They can be as wide as 1 millimeter. They're usually a lot smaller. Snow crystals can also be columns. Look at these guys. Column-shaped snow crystals are shaped like pencils. They're not flat like stars and plates. Columns can form high in the clouds and at very cold temperatures. They're very tiny, and when they fall, they make for very slippery snow. A column has 6 sides. These are the 3 types: a solid column, smallest kind, a hollow column, which are longer and more common than this guy, or the capped column. The caps on each side of these columns can be plate crystals or star crystals. So which kind is that? Yeah, that's a plate. Actual size. This is actually the size of this column crystal. Capped columns, like this one, develop when a column crystal moves into a part of its cloud where the temperature is right for plates or stars to grow at the ends. The 2 end caps can grow to different sizes, as you can see here. So one end cap is bigger than the other. That seems rather large for a snowflake. Six is the magic number for snow crystals. This is because of the nature of water. Water molecules, the smallest units of water, attach themselves into groups of 6, which usually leads to crystals with 6 arms or 6 sides. A perfect star or plate snow crystal has 6-fold symmetry. That means if you divided the crystal into 6 pie wedges, each pie wedge would have the same shape. So I don't know if you can see the lines of symmetry they've drawn, but basically like that, and like that along the arms. And then each of those pie wedges is symmetrical. Water molecules attach to each other in 6-sided rings, like 6 kids holding hands. When many of these hexagonal rings are joined together, a larger hexagonal crystal is formed. Does this remind you of anything that an insect makes? It's an insect I like a lot. Snow crystals are rarely perfect. So much can happen during a snow crystal's fall to Earth. it is rare that one will turn out perfectly. If a droplet of water passes close to one arm of a snow crystal, that arm can start to grow faster. Before long, that one arm will be a lot longer than the others. Oh, here's an example of an imperfect snowflake that is not really symmetrical because this arm grew pretty long. These are also imperfect. Can you see the long arms? A snow crystal can be a twin. Wow, and I thought they were all unique. A snow crystal can have 12 arms. This is a twin crystal, which happens when two crystals start from the original speck and form on top of each other. Whoa, it's like a double snow crystal. A snow crystal can have bumps. If there are enough water droplets near the crystal, some can strike the crystal and freeze on contact. This gives the crystal little bumps called rime. I don't know if you can see those little bumps in this camera, but they look kind of like little specks. Many snow crystals make one snowflake. Often, snow crystals bump into each other and get stuck together. When this happens, snowflakes form. Hundreds or even thousands of snow crystals can be found in a single snowflake. Snowflakes we see falling from the sky are actually clumps of snow crystals like these. Individual crystals, which are sometimes also called snowflakes, can fall on their own, but they are much smaller and harder to see. This is a picture of two snow crystals that stuck together to form one flake. Once a snow crystal lands, it starts to wither away. Snow crystals can't keep growing after they fall from the clouds, and when a crystal stops growing, it immediately starts to wither. Soon the arms of the crystal break down and the crystal's shape becomes rounded. This means that if you want to see a snow crystal, you need to catch it in the air or find it very soon after it lands. When they're not in the clouds, surrounded by the water vapor they need to grow, snow crystals quickly start to erode. Try catching one in your sleeve or glove to see the crystal structure at its best. Oh, someone caught one here on a wool mitt, I think. And it's still nicely preserved. Have you ever seen one like that? With its branches intact. Pretty rare, but so beautiful. Are no two snow crystals alike? Some simple plate crystals may appear exactly alike, as seen through a high-quality microscope. When it comes to more complicated snow crystals, though, odds are that no two are exactly alike. But then, no two leaves, flowers, or people are exactly alike either. Snow crystals are like us. We're each different, but we have a lot in common. Tells you all about how to catch your own snow crystals. So it's going to snow maybe. And they're saying a piece of dark cardboard or foam core board. And basically you put it outside 10 minutes. And then you hold it by the edges. And it should fill up with snow. And then you look at the board. And you use a magnifying glass. So you catch crystals on a board. But it has to be dark. So you can see the white crystals against it. And then you can look at them with a magnifying glass. In the right kind of snowstorm, you should be able to see many individual snow crystals. Snow catching tips. Make sure it's cold enough. If the snow melts when it hits the board, or if rain is mixed with the snow, it will be the temperature is too warm. Look for tiny snow crystals, not big snowflakes. Remember, snowflakes are lots of snow crystals clumped together. Sometimes the snow is all broken up and looks like a light powder. Not every snowfall has unbroken snow crystals. If the snow just isn't right, don't give up. Try again on another snowy day. Or wait till you go on a ski trip. A snow crystal is a letter from the sky. Ukichiro Nakaya, Japanese scientist, 1900 to 1962. And that's the end.